My work focuses on the kind of the intersection of developmental psychopathology, where we understand how mental health problems develop, and affective neuroscience, where we understand the neural bases for emotion and emotional processes. And I'm going to present findings from several different studies, including putting things in a context for you, hopefully. And the good news is I noticed from Jay's talk that he and I and then Sue will all have the same slide at one point. So there'll be like nice continuity and overlap. So you'll see it, you'll be familiar with it. To start with a perspective on why this is important and what we're trying to understand here, I have an example and a quote from a blog called Hyperbole and a Half, written by a woman who's in her early to mid-20s, who describes lots of things about her life, but who has very poignantly described her experience with depression. And I think it's touched a lot of people and helped a lot of people understand what depression is like. So she draws herself like this little frog-looking creature, and she describes what she's like, what she's feeling when she's going through a depressive episode. And she says, I wonder what today is going to be like. And she says, at first I try to explain that it's not really negativity or sadness anymore. It's just this detached, meaningless fog where you can't feel anything about anything, even the things you love, even fun things. And you're horribly bored and lonely. But since you've lost your ability to connect with any of the things that would normally make you feel less bored and lonely, you're stuck in the boring, meaningless void without anything to distract you from how boring, lonely, and meaningless it is. I have an example of her. You can link to her blog here. There's also a really nice, interview with her on this website. But this points out some of the really critical aspects of depression I think deserve more study. So one, that it doesn't just involve feeling more sad or feeling cranky or having difficulty with negative emotions. It also involves feeling less positive emotion, not being able to engage with the world, not finding the things you typically would enjoy enjoyable anymore, and not having motivation to even try to do that. And again, even if you were motivated, you just wouldn't have the energy, and you have this pessimistic belief that it won't matter no matter what you do. So the overall message I wanted to convey with this talk are that to understand how people get to this point where they develop depression and are experiencing such pain and such difficulty in their lives, we have to apply a developmental psychopathology perspective. I hope that's going to come through in the entire lecture today. That we can't really understand atypical development without understanding typical development. So it's important to know how typical development occurs in brain structure or in brain function. And that furthermore, a developmental psychopathology would give us a focus on, say, longitudinal work, knowing that every disease first occurs as kind of an endpoint. It doesn't just sort of arise immediately. It has a whole foundation before it's there. Everything occurs gradually and starts earlier than its onset. Of course, this is true with neuropsychiatric diseases as well, and that something like depression has its roots very early in life. Another point is to embrace individual differences, which Brad brought up in his talk yesterday, so I'm just citing his talk here. But the idea is that we see variability in typically developing people that can help us understand the circuitry and the mechanisms of depression. We see variability within people who have depression or within people with any disorder. Again, some of that might be attributable to this sort of artificial psychiatric diagnostic constructs we've created, but some of it could just be this typical underlying variability that can help us understand what's going on. Another one is to consider the context. So because I'm a clinical psychologist and a developmental psychologist, I think not just about the brain, but I also think about the social context and the function of affect and its role in helping us live fulfilling lives in our social domains and in other domains too. So to put things in the context of social experience and functioning. And the point of all this is really to understand how to help people, that we want to relieve suffering. We want people to be able to live their lives with enjoyment and meaning and to create something that's worthwhile for them. And for depression, like with many of our disorders, the treatment is very disappointing. It works for some people, but even with the largest multi-site study we've had of adolescent depression treatment, the best is that 70% could improve with a behavioral treatment. So 44% got better with the behavioral treatment alone, cognitive behavioral therapy. 61% improved with a pharmacologic treatment, and 70% improved with both. So maybe the message is for some it's good to have both, but the big message for me is 30% of people didn't improve. And imagine thinking about that. If you had an illness and someone said, well, you have a 70% chance of surviving or doing better or getting past this, it's really disappointing. So to think that we have these treatments and they're not as effective as we'd like. And there's an important need to understand how to have better treatments. And that maybe the best way to do that is to really get a better understanding of the mechanisms underlying these disorders. And with depression, I should also note, if we would consider schizophrenia a common disorder among the neuropsychiatric disorders, depression is super common. It occurs in, looks like 20% of people. Women, it's higher than that. It's 2-to-1 prevalence in women versus men. It's quite common. It's the leading cause of disability worldwide, I think, at this point. So it interferes quite a bit with people's lives and people's ability to function. So if we can understand how to deal with that better, I think it's going to improve a lot for lots of people in the world. A point that's come up earlier in this school, and more in terms of understanding the kind of genotype to phenotype connection, is this notion that you can't really start at one point and think you understand what's going on. So you could have one outcome at which you arrive from many different paths, or from even different causes. So just because two people seem the same in terms of their symptoms or their experiences doesn't mean that there's the same thing going on when you're dealing with your patients. Or another possibility is that it is the same thing going on, but you just have different ways to get there. Another point is multi-finality, where you have a cause, so say a genetic variant, and it could lead to many possible outcomes, again, because of the internal genetic environment, because of your external experience environment, because of lots of reasons, but that you wouldn't necessarily, knowing this doesn't necessarily tell you what you would expect for someone. And again, with development, that's important. So if you have two twins, like Jay was talking about, you don't know that they're going to end up, the same with, both having ADHD, for example, or having similar experiences in life. Or if you have two people who do have ADHD, it doesn't mean that they've, gotten there the same way. Models of adolescent brain development have, in general, focused on balance among systems, because as Jay was saying so eloquently, adolescents are famous, I think maybe in their families or in the media, for getting themselves into trouble, doing these foolish reward-seeking things. They seek out intense experiences, they drive too fast, they try drugs, they do sexually risky things. And so I agree that adolescence is not a problem time, and I think it's an important part of exploring and becoming independent and developing an identity, and that's the function of a lot of the things that adolescents do. And we have to accept and embrace that too, and say they're doing what they're supposed to be doing. But it is puzzling, I think, to understand why things are different. Adolescents do things that children don't do, or that adults don't do. And a common explanation is that this triadic model sort of proposes that it's the balance of prefrontal kind of control systems and executive function systems, and the balance of those with sort of reward or approach-oriented systems and avoidance-oriented systems. And I know here we are falling into this trap of focusing on regions rather than circuits. That's another point I want to make. I'm not saying that everything boils down to just the ventral striatum, for example, that everything operates in circuits and that circuits themselves are interacting. But the kind of in the most simplified form, one possibility is that in adults you have this kind of balance among the three, and there's a challenge balancing between ventral striatal approach type behaviors and systems and amygdala-mediated avoidance, and that you kind of have the balance, and that's all maintained by the prefrontal cortex. In adolescence, in contrast, this view would say that you're tipping toward approach. The adolescents are doing more reward-driven behaviors, or they're engaging in more rewarding, approach-oriented, but kind of risky experiences for themselves. And that's because, in this view, there's kind of inappropriate modulation and kind of balance among the three, so that you're getting more weight on this ventral striatum approach side and less on this amygdala side. And that somehow the prefrontal cortex isn't quite, keeping things in balance the way it's supposed to. So things are getting kind of pulled in this direction, and what you end up with is risky or problematic behavior. And I would argue, too, that you can classify depression in this category, too. Even though it doesn't involve risk-taking or risks like that, it does seem to involve disruption of reward circuitry and reward processes. Another model, which is the part of the model that Jay was also referring to, is a dual systems model, which is a similar thing. That basically, to simplify it and boil it way, way, way down, you have this earlier maturing striatum, which there in this case is being, representing this tendency toward reward and tendency toward seeking exciting experiences. And you have a later maturing, or maybe a sort of different pattern, more linearly maturing prefrontal cortex. And again, it's a mismatch between the timing and pattern of maturation in these two that's leading to problems with reward and problems with sensation seeking and things like that. And that, for example, these become kind of more reciprocally associated with each other, and that's kind of keeping things in balance in adults. But in adolescence, you don't have that kind of inhibition from the PFC to striatum in this model. Evidence from this has been from examples like adolescents showing differences in behavior or experience or brain response to rewarding events. So in this case, this is an emotion context executive control task. So basically, they're seeing, I think, happy faces, like different facial expressions while they're completing this control task. And the adolescents tend to show more false alarms when they're looking at when they have a happy face context. So again, they're more sensitive to rewarding stimuli, maybe. And that's changing their behavior, making them perform worse, which maybe tells us why, adolescents have all the kind of abilities to do things well, but still make a lot of mistakes. And similarly, they're showing more response in ventral striatum than when they're seeing happy faces than children or adults are. So this is provided as support for this view that there's this difficult with balance and that this is related to behavioral and kind of brain function outcomes. This has been challenged, though. I think some people have said it doesn't completely suffice to explain what's going on with adolescent development. So again, the dual systems model would say that things are maturing, the kind of more emotion-driving areas and systems in the brain are maturing faster and on a different pattern than the more control-focused parts of the brain, like the prefrontal cortex, and that this kind of gap here is what gives you the chance to get yourself in trouble if you're an adolescent. You're going, maybe you're going to be more sensitive to reward, more driven towards seeking reward, more motivated for it, but less able to control it and manage it yourself as well. But another view, the challenge of view of this says, well, if that's the case, then that would explain some disorders, but not others. So basically, I'll back up and say that people have said, this is what's going on in psychopathology. And I see this a lot, especially in people I think who are kind of new to looking at things from a neuroscience perspective. And they'll say, okay, what's happening in anxiety, borderline personality, or depression, or especially disorders involving affect disruption, is that there's too much limbic or kind of subcortical or kind of affect reactivity responding and insufficient control from the prefrontal cortex. And that's why these disorders might be arising during adolescence at this time when there's this big gap here. And the challenging view says that doesn't really quite make sense, because if that's the case, things should peak at adolescence when there's this gap between prefrontal and subcortical development, and then they should resolve once prefrontal cortex has developed and things are more in order and everything's more regulated. And that story makes sense for substance use problems, which actually do seem to have this peak at a time when maybe one set of systems is maturing before the other, but doesn't make sense for depression, because depression also goes up around these late teens, but it stays up. It doesn't, unlike, say, substance use or alcohol abuse, which peaks around age 20, then goes down. People still experience the problems with addiction, but there's a certain developmental vulnerability here. And with depression, you think, okay, if this problem of prefrontal cortex not regulating subcortical, it'll go up, it'll go down. So it doesn't. So that's one challenge. Another one, of course, is that it's not, things aren't quite so simple. So as we saw in Brad's lecture yesterday, we can't think of anything being localized to a region, even to a lobe, even to dorsal or ventral or rostral or caudal parts of the brain. That systems involve multiple regions working in concert. They're not necessarily located, right adjacent to each other, and that we have to think of things in a perspective of functional systems. So again, saying that prefrontal cortex does one thing and this whole subcortical system does something else, it just doesn't really make sense and isn't borne out by the evidence. And even among adolescents, I'll point some of this out with some of my own findings, there aren't consistent findings of enhanced response in the ventral striatum to reward. There's some studies, like one of ours, that have found less response, for example. So it's not quite clear that that's the whole story. And in fact, ventral striatal response isn't necessarily a bad thing. I mean, they're saying that maybe there's more response, and that's why adolescents are getting into trouble with drugs or bad driving or risky behavior. But again, like any functionalist who studies emotion or anyone with an evolutionary perspective will tell you everything has a function, everything has a purpose. Maybe there's a good reason for having a different balance among systems at a certain point in development. And that there are times when it's adaptive to have more ventral striatal response. Of course, it has complex functions too. It's not simply this reward processing area, like everything is localized to that one region. And furthermore, of course, it's not as if the PFC has one response, of course, and that it even is just focused on self-regulation. And furthermore, that heightened response in this area refers to better functioning or better self-control. So again, depression is an example of this. Another argument against this point of view is that the point at which these two areas are mismatched in their development, at least structurally, is not the point where all the problems arise. It's the problems arise later. So if there's this mismatch, say like in the early teens or mid-teens, things really heat up in terms of substance use problems, depression, other kinds of serious problems, more like in the late teens, early 20s. So it doesn't quite fit the story. So just not that I'm saying there's not a good heuristic value to the dual systems model, but I think it's got some important caveats. I think there's important things to consider. Positive affect, again, is an area that's been understudied in depression, but is worth understanding because it's so relevant to the disorder and the form that it seems to take. So there are several different symptoms, and there are also correlates of depression that are probably relevant to positive affect systems and reward systems. One of them is anhedonia, which is a key diagnostic symptom in depression. It involves difficulty with having motivation to obtain or difficulty with enjoying pleasant experiences. And this is the kind of thing that the author of Hyperbole and a Half was describing in her experience. She just can't enjoy things anymore, she can't get engaged in anything, and even thinking about getting involved in something doesn't appeal to her. But other symptoms too, including things like fatigue, even kind of more, fatigue or appetite or sleep could also reflect low positive affect. The depressed mood, that's sort of the hallmark symptom most people think of when they think of depression, could reflect lower positive affect as well as higher negative affect. And even kind of associated behaviors like social withdrawal could probably also reflects difficulty engaging positive affect systems. And positive affect has a role in the clinical course. I'll mention that later. So this is a cartoon of an adult, but it says something important for understanding depression, where this person is on the phone saying, "This is one of those days when I would have been better off just getting out of bed and leaving the house." And of course, that's an argument we'd make with depression, that every day is one of those days. No matter how you feel, you should be getting out. You've got to get out there and experience that reinforcement and that reward. And part of the problem with depression is that you're not giving yourself opportunities, is what a behaviorist would say. You're not giving yourself opportunities to get reinforced for your behavior, and that will feed back to your mood. You're not having a chance to improve your mood, and you're maintaining this difficult mood or low positive mood. And depression has been conceptualized then as a disorder of affect regulation. This has been the case for a long time. And as I mentioned, most of the focus, though, has been on negative affect. There's a huge literature on understanding, say, amygdala response to negative stimuli or threatening stimuli. And that certainly seems to be part of the story. And what's less studied, but has been conceptually part of depression models for a long time, is positive affect and how that's reduced in depression. So there's difficulty with modulating and controlling flexibly high levels of negative affect. But probably there's also differences in maybe enhancing or maintaining positive affect. And one example I think of when I think of positive affect and what's maybe different about it in depression isn't necessarily that people don't experience it, but maybe they're not able to kind of sustain it the way they should. So an example is from a patient I saw who was in her 50s, had experienced a long course of depression, had quite severe depression, had been hospitalized. And she was coming in one day telling me about an experience she'd had on her way to her appointment when she was driving. And she saw a woman by the side of the road playing with a little puppy. And for a second, her heart just warmed, and she was so touched by this puppy who was so floppy and fluffy and adorable. And then a second later, she just crashed and thought, not literally, but like her mood just crashed, and thought, oh my gosh, I'll never have that sort of pure happiness in my life. That's not for me. That's not what I experience. And I thought, oh my gosh, you had it for a second. Like she was able to generate that, but then she couldn't keep it going, and it, went to the other direction. She became really, really sad and really depressed about it. So again, it's not that maybe you can't generate it or there's something missing at the kind of early stage of the temporal process of positive affect, but then maybe there's some difficulty with allowing it to unfold properly without shutting it down or dampening it. Positive affect, again, has had a conceptual role in depression for a long time, and so it's worth studying. And I should note that more and more work is considering this aspect of depression. And positive affect itself has an importance in our functioning as social creatures, that it promotes affiliation. So again, with these young people who are all posing for their selfie together with an old-fashioned camera, so it's an old picture. Now it would be a phone. It's dated, I gotta change my picture. Anyway, but they're enjoying being together, they're connecting with each other, they're enjoying friendship. This is what positive affect does. It helps us engage with other people and receive the rewards that we receive in our social context, which is, some would say is really the point of being human. And of course, with young people, one thing I was thinking about during Jay's talk when he was talking about development is what does it mean for adolescents to miss out on some of the typical experiences of adolescence because they're depressed? So what does it mean for their social development? Do they not understand how to make friends the same way? Do they have difficulty kind of enjoying the thing? I mean, social functioning is such a focus of adolescent life. If you're not really functioning properly, what does that mean? What does it mean for brain development to be in this period of your life where maybe you're not engaging with others, you're not enjoying things, you're finding it difficult to be motivated? What does that mean in terms of at a time when your brain is still undergoing important development? And positive affect actually has a role in the development of depression. There's some interesting findings that, for example, adolescents who have the symptom of anhedonia, so difficulty experiencing pleasure, but don't have depression are more likely to develop full-blown depression in their early adult years. Or adolescents who are depressed and have higher levels of positive affect are more likely to recover from that episode and less likely to have a recurrence with another episode in the future. So this underscores, again, the individual differences point of view, that not everybody we say is depressed is the same, or that even among people who are depressed who generally have low positive affect, there are some who have relatively higher. Maybe they're the ones who have better outcomes and better functioning. But again, we need to know that, and we need to know who's going to do the best with which treatments. You know, is it the people who have a certain pattern of brain function or experience or behavior? You know, are they kind of functioning at a better level in the first place, even though they're experiencing this problem? We still need to understand this a lot better. Reward, of course, is an important part of adolescence. So as we've said a lot today, a lot of the behavioral differences in adolescence are related to reward. And there's an increased focus on social reward. So of course, friendship and relationships are very important in childhood, but with adolescence, they take on a new meaning and a new intensity. So suddenly people are more aware of who the right people to be friends with might be, or how they rank in comparison to others. Or friendships become more intimate. You suddenly have someone you can confide in, you really can share your experiences, you feel like someone can maybe understand your mind. It's a really powerful experience. And of course, romantic relationships begin at adolescence too. So the social domain takes on a whole new meaning. And another point of this, as Jabe was mentioning, is to individuate from your family, kind of strike out on your own and develop your own identity in life. And of course, nonetheless, parents still remain very important, and they're a strong influence on adolescents' functioning and their mental health. So again, you have to balance this like increased interest in peers and concern about your standing with peers with the importance of maintaining some kind of relationship with your family and your parents. And one of the models of depression and why it develops during adolescence focuses on the prefrontal cortex and its role in being able to set abstract goals and do things like track progress toward those goals and evaluate how well you're achieving them as part of maybe the kind of perfect storm that converges in adolescence to lead some people to become depressed. So in their view, it's not this idea that the prefrontal cortex is lagging behind and isn't able to regulate the more kind of affect reactivity systems in the brain, but their view is actually more that the prefrontal cortex is just developed enough to allow some people to become depressed. So in this case, they are able to set a goal, like being friends with a group of people who are popular at their school. That goal is very dearly held to them because social goals are important. And then they're able to evaluate, how well am I doing? They're really always kind of mean to me, and they don't really seem to like me, and when I try to hang out with them, they're not that welcoming. So maybe I'm not going to be friends with those people. I'm not going to be in the top social group of my school. For some people that would be disappointing, but not important, or not as critical. But for some, that could be a really crushing disappointment. And so to be able to set these abstract goals and track progress is an important characteristic maybe of this kind of convergence of social reward emphasis, dopamine system development, brain development that leads some people to become depressed. In terms of understanding reward, there are several different aspects, like motivation to pursue pleasant experiences. So you might have an adolescent who was typically spending lots of time with friends or texting friends or staying in touch and just isn't interested in doing that anymore. So for some reason just isn't pursuing that. Has difficulty enjoying pleasant experiences. So maybe is able to go as far as being with friends, but then doesn't really get much out of it and feels kind of sad and disappointed. Another one is different decision-making about pleasant experiences. Kind of somewhat counterintuitively, there are findings that people with depression can be more impulsive. Maybe, again, judging that, they should just do something now because the future doesn't hold anything good for them. Maybe because they're not able to kind of make, decisions in the same way, but there's something different about their reward or decision-making, because that could be the case too. And there could be altered reward learning. So adolescents who are depressed might have difficulty with kind of learning from experiences. And this could be the case in adolescents in general. There could be differences in reward learning that explain some of the differences in behavior. And the circuitry for reward is probably well known to lots of you, but involves areas like the ventral striatum, a very basic and critical region for reward function. As Jay pointed out, essential to all kinds of functioning. The nucleus accumbens is in this region. Obviously, midbrain areas, the medial prefrontal cortex, which I'll emphasize quite a bit in this talk, and orbitofrontal cortex are involved, and the amygdala, which again, I think in the, sometimes in the affective neuroscience or clinical neuroscience, or even just lay media world, is reduced to like a threat-related area, has a role in reward too, of course. It's not surprising. I mean, of course, there are projections to the ventral striatum, to the nucleus accumbens from there. Again, so it's a whole system that's relevant. And the areas that I'll focus on today are just two within this whole system. One is the striatum, which in this case is going to include the ventral striatum and dorsal striatum. So the nucleus accumbens and ventral areas, and then dorsal areas as well. And then the medial prefrontal cortex, which has quite a few functions. It's a large area, obviously. But again, it's important. These both are both the targets of projections of midbrain dopamine neurons. And they have connections to each other as well. And they're both important basic areas that respond to reward. So to try to capture reward responding in adolescence and understand how that changes typically or in those with depression, we really try to focus on what's rewarding for them. It wouldn't be surprising to think that winning or being part of a team is rewarding. Having friends, having a lot of friends could be rewarding. And we've tended to focus on one that's probably not the most dearly held human kind of reward, but works nonetheless, which is winning money. So in this case, we have Little Wayne and Fat Joe with $100 bills raining down on them. And again, I think this probably isn't the most potent and salient kind of reward, but it's the kind that works. And we only give kids $1 every time they win a trial. I should know they don't get a lot of money, but it still works. But we've tried to capture the more meaningful kinds of reward too. Maybe that's going to give us a better sense of these individual differences that tell us who develops depression or who struggles with mood or who's going to engage in more risky drinking behavior, for example. So another one we focused on more recently that's very familiar to adolescents is feedback that people like you, so social reward in a very standardized kind of way. And this is a common experience and also meaningful. But of course, I'd argue that the most important kind is this sort of more personal, more social kind of reward, knowing that people like you and care about you, that you have connections to others. Of course, this is the hardest to operationalize and bring into the lab. But again, we strive for finding ways to make this work ecologically valid so we can understand how people's experience in their real lives can be reflected in their brain mechanisms. So we do functional MRI. You're familiar with this from so far. And again, it's tracking, responses, very slow temporal responses. So they're not occurring in milliseconds, they're occurring in, say 9 seconds long. It's a much, much slower response. It's related to, as Brad was saying yesterday, something more, kind of more holistic, more metabolic than just simply neuron spiking, neuron firing. So it tells us something valuable, and it can give us nice spatial resolution. So it gives us a sense of like where, which regions in the brain are involved. This reward task I've focused on the most, and we'll be presenting most data on today, it just focuses on winning money. So this was very simple. We've used it with kids as young as 8 years old. We've used it with adults into midlife. And it's notable for being able to nicely and reliably engage those two regions I was mentioning, the ventral striatum and the medial prefrontal cortex. And I'll just walk you through a trial to show you. It's very simple. It doesn't require a lot of learning or practice or anything sophisticated. You just guess. So you find this card on the screen and have to guess whether it's going to be high or low. Then you have the anticipation period where you're waiting to find out what's going to happen. You see these hands shuffling cards. This up arrow means that it's a trial where you might win. So if you're correct, you'll get $1. And if you're not, you'll just come out even. Then you find out what happened. So you get the number. If you guessed high, it was a high number, so you're right. And then you get a confirmation with this upward arrow. And then you watch a crosshair and wait for the next trial to begin. So it's very simple. We try to use this task in some ways to separate anticipation from outcome. It doesn't necessarily, it doesn't always necessarily end up being fruitful to try to do that. In some cases we've seen that they're pretty similar. If you want to talk methodological stuff, I can explain to you that we now have jitter in the task, so we're able to separate a little more confidently. But again, you could argue that because the bold signal is so slow, what we're really measuring maybe is a lot of anticipation and less outcome because it's extending into the next time. The other thing I want to mention about this is that everything is determined ahead of time. So all the trials are in this fixed pseudo-random order. And the point of that is that we want to make sure everyone has the same experience in terms of winning or losing, and then we can measure their differences in response to that experience. So it wouldn't be good if I lost my first 3 trials and you won your first 3 trials, because right at the beginning of the task, we'd be having a completely different experience. Maybe for me, that would like ruin the whole task and I wouldn't be responding. And maybe for you, that would set this stage where you're feeling really excited and happy for the whole task. So people of course are going to respond different ways, but at least we can control that, kind of the way the stimuli are set up and the way the outcomes of the trials are arranged. So what we found, basically, and this has been now supported with meta-analytic evidence in adults, there's not as much in adolescents and young people, but it's consistent with this, is that people with depression show less response in the striatum, in this case adolescents who have depression, show less response than their typically developing peers who are around the same age. And this is pretty easy to explain in terms of the idea that there's less positive affect, there's difficulty regulating reward systems in depression, and so we're seeing less responding in this very, very basic and important reward area that responds to every kind of reward in life, food, drugs, other things like that too. So that's not so tough to interpret, so that's good and consistent with what we would predict. And then we see more medial prefrontal response in depression, so in adolescents with depression. And I want to just remind everyone about this patterns where we're seeing less ventral striatal or less striatal and more medial prefrontal, because that sets the stage for a bunch of things I'm going to describe. Again, I don't mean to oversimplify to 2 regions or 2 very specific parts, but it kind of helps me tell a story, and I think it will give you a way to interpret the context of the other patterns we're seeing in typical development too. In this case, it's kind of an interesting one to interpret. So there are 3 possible explanations that we've come up with that would explain why we're seeing less response in striatum and more response in medial PFC. One possibility is that the medial PFC is overregulating the striatum and kind of shutting it down or dampening its response. And that's what might be happening when someone has an initial happy response to a pleasant event and then no longer has that response and then stops feeling happy. So that could be the case here. Another possibility is it's maybe signaling the striatum to respond more and it's not being effective. Another one is that, going back to Brad Schleger's talk yesterday, this is an important part of the default mode network, and that the medial prefrontal cortex is one of the key regions in that network. And part of the point of the network, people think, is because it's really active when we're at rest, just alert but not engaged in any task. One possibility is that the focus of the network and its function is to process self-relevant information. Because again, when we're just like awake and sitting and not really engaged in anything, we're thinking, okay, what time is lunch? And what do I need to get ready for that trip to Ravenna? And I have to return that email, and I got to call my mom, whatever. Like all those kind of things are just related to ourselves and our lives. Some things more important than those for sure, but they're kind of self-relevant material. And certainly in depression, people are overly engaged in self-relevant material in a negative way. They think, I'm a loser, I've had a terrible life, nothing goes well for me, people don't care about me. Anyway, they tend to focus a lot on their shortcomings, but nonetheless on themselves. And some of that is related to rumination, which is a characteristic of depression too, where people kind of get stuck cognitively and kind of focus on these negative self-relevant issues, or trying to solve these problems in their lives that they are not able to solve. So that might be reflecting this too, that maybe they're stuck in this self-referential loop and they're just constantly focused on that, and that when something pleasant or rewarding happens, they can't switch out of that, and they're showing more response for that reason. Another kind of reward we've used is a standardized social reward task. So in this case, you come into the lab, rate pictures of other people based on how much you think you'd like them, and are told that they're going to be rating you, and then when you come back a week later for your scan, you get feedback from the other people in the study. In theory, it's not quite true, and we debrief them later that it's a deception, but they believe that these people are rating them and giving feedback about them. So while they're in the scanner, they have blocks where they get positive feedback or positive information. So these people with the green background said they would like you if they met you. And then they have other blocks where they get neutral feedback, like, oh, these people you rated, but they didn't get a chance to rate you yet, so we don't really have any information, we'll just show them against this darker background. Of course, no one was really rating them. The other thing about this task is it was developed by Chris Davey at University of Melbourne, and he deliberately didn't include rejection or negative feedback blocks. He didn't want to be able to have something, have the experience of people not liking you then carry over and ruin your chance of maybe enjoying feedback that people liked you. So he wanted to focus on being liked or just no feedback or neutral feedback. Of course, you can argue that in depression, people might still find a way to interpret the neutral material as negative. So they might be able to say, well, the person didn't rate me, but if she rated me, she probably wouldn't have liked me anyway, or I wouldn't, so they still could find a way to spin it so it's negative, but nonetheless, they don't get actually feedback that people didn't like them or gave them a negative likability rating. So we know that one of the most rewarding things for adolescents is social interaction with their peers. We know that a lot of positive affect is generated in these kind of settings, and we know that a lot of the risky behaviors adolescents engage in are happening in peer social contexts. So it's much more dangerous to drive with a car full of your friends when you're an adolescent than to drive by yourself. You'll stop at the stop sign, you will not drive as quickly, you're gonna be more careful and less risky. So we thought if we can capture kids in this kind of context, maybe that's gonna really tell us the most about individual differences in who develops reward-related problems, say with mood or with drinking, or with sexual behavior. And we tell them to have a conversation about anything they want, but focus on the most fun they've ever had together. So we get all kinds of interesting responses. These are examples of the kind of tame ones. We've heard it all. We've heard about drugs, we've heard about sex. The good news is I think it means they're very open and they're not kind of censoring themselves and letting themselves talk about what they really like. But yeah, we get a whole range of stuff. So these are the kind of more clean ones we've heard. So then we videotape this, we code it. So we're gonna have data on their behavior during the task. So we'll know, for example, who's more positive, how do they kind of interact together, how do they respond to each other. And then we show them videotapes from this task in the scanner. So again, it gives us a chance to understand how reward systems in their brain are responding to this pleasant stimulus. In this case, it's a very important pleasant stimulus to them because it's someone they really like and care about, talking with them about an experience they shared together that was a kind of exciting, positive experience. So we'll see videos of their friend showing positive affect or neutral affect, so we code it and select those sections. And then they'll see another kid, around the same age, same sex, showing the same thing, neutral affect, positive affect. They see each one 3 times. They have a rest in between, and that way we're hoping to be able to capture they're responding to someone important to them, again, an important experience that was shared with that person, versus someone who is around the same age, is the same sex, but is a stranger, and they don't have any history with. So we found that to be fruitful too, and I'll present a couple of findings later. We also measure behavior. So we want to measure things like, of course, their behavior with their friends, so their affective behavior, which we observe, but also things like basic computer tasks, where they might have to work harder and harder and harder to get the same rewards. So we can see how motivated they are to work for something. Or, for example, being able to learn about rewards, so being able to develop a bias over time when your responses are reinforced. It's an important thing that distinguishes actually adults with depression from adults who are healthy. So maybe that's different in adolescents as well. And then even being able to make decisions about receiving small rewards now versus waiting for bigger rewards in the future. So our findings of typical adolescents cover a few things, and some of these I will note are actually related to depression as well, because one of our interests is understanding just depression as it typically occurs in people who are pretty much healthy. And adolescents turn out to be a good time to study this because there's more variability. The typical adolescent has kind of higher level of depressive symptoms than a typical adult or a typical kid. It doesn't mean they're having some diagnosable problem, doesn't mean they're in some critical state. It just means that there's different variability in mood in adolescence, and it really allows us to understand the underlying aspect of that variability. So we found in one study that, and this is the one I was mentioning earlier, that we see less response in the striatum to reward in adolescents compared to their less mature counterparts or even compared to adults. In this study, one of the goals was to understand puberty and how that influences brain development. So kids were recruited in a really narrow age range where they would vary in their pubertal development, so based on their hormones or their physical appearance, but they wouldn't vary much in age. Because if you've got a study of 10 to 18-year-olds, you're going to have puberty and age pretty nicely correlated, so you're not going to be able to say what's what. In this case, we're trying to restrict the age and allow puberty to vary. So anyway, what we found is among these kids who are basically the same age as each other, those who were more advanced in puberty based on their physical exam were showing less responding to reward than the ones who were not as mature. And again, this is an interesting one because it doesn't fit the model of there should be more ventral striatal response or more striatal response to reward in adolescence. But I think a thing to consider here is that it's not as nuanced as that. It's not just that every reward is more exciting for adolescents. Certain rewards are more exciting, or maybe their threshold is higher. So in studies that have used different magnitudes of reward, they've often found adolescents respond less, like here, to a smaller magnitude, but respond more to a bigger magnitude. So maybe they don't get excited until it gets to a certain point, but then they really go over the top. So I think it's worth considering that too. Under what circumstances do we see increased responding, and what does it mean? And here we saw, even among typical adolescents in the same study, those who had more prefrontal response, medial prefrontal response, again, the pattern we see in depressed kids, showed higher depressive symptoms, just along a normal range. But interestingly, that was moderated by development. So we saw this puberty by brain interaction, where it was only among the mid to late adolescents, based on their physical development, who were showing this association. So does something change, not with age necessarily, or with development, including puberty, that somehow makes this pattern of brain function, these mechanisms, more related to people's experience, people's mood? And similarly, a former postdoc who's now faculty, Judith Morgan, in our department, did a project where she wanted to understand who had an increase in symptoms. In this study, it was a study that was conducted by Ron Dahl, and he was trying to understand maturation and development during adolescence, and he actually brought the kids back a second time. So we brought them back and did other stuff. We didn't do a second scan, so we don't have a baseline scan, but we have data on their depressive symptoms at 2 ages, 2 years apart. So the kids were 11 to 13 at time 1, and then 13 to 15 at time 2. And Judith's question was, can response to reward in these kind of standard reward-related regions tell us something about who has an increase in symptoms from 1 point to 2 years later? And she found that there was association. So again, more response in the medial prefrontal cortex, which we see in depression, was related to greater increase in, less response in the striatum, was related to greater increase in depressive symptoms. So that kids who had that pattern of responding that we see in those who have depression on average had that greater increase. But interestingly, again, she found it only in the ones who were mid to late pubertal. So those who were more physically mature were showing this association with change over time and predictive value of this brain response. So interesting to think of what that neural response means for one group that's a little more mature but the same age compared with another group. And then I wanted to present some findings on the social context in terms of the family and brain development. This is another project that Judith Morgan worked on. This one is actually based on another study that I've been really lucky to collaborate on. It's called the Pitt Mother and Child Project, and it's been run by Danny Shaw, a colleague of mine who's in the psychology department. His focus was to study the development of antisocial behavior in kids. So he started with this all-male sample when they were 18 months old, and they're a low socioeconomic status, so they were recruited from a government-funded food program. And he's followed them now until they're 23 years old. And I was fortunate to get involved at 20 and start doing imaging on them to understand their brain function and brain structure. But we've got this amazing wealth of developmental data on things like their neighborhood, family conflict, the parenting they've received, their mental health from age 9 on, their impulsivity, all kinds of interesting characteristics. And so with these data, we've been able to ask some really interesting longitudinal questions. So one question is, do we see relations between parenting and brain development, or parenting at one point and brain later? Can we, because we have this evidence and we have this hypothesis that low positive affect or disrupted positive affect and reward function are related to depression, is there something that's going to be important for understanding positive affect that kids experienced in the context of dealing with their parents that might tell us their pattern of brain function or their pattern of neural response later? So in this case, she used data that was from age 24 and 42 months of a play interaction between a mom and her son, and another interaction that was at 10, 11, or 12 years. So she had 2 interesting developmental points. One's the toddler years, when there definitely is some conflict, things need to be worked out, kids are saying no and trying to find a way to get what they want against a parent who's trying to convince them that they have to do what the parent wants. And it was a pretty positive interaction task, but even so, a time when there can be some challenge in the parent-child relationship. And then again, at early adolescence, where they had an interaction more trying to solve a problem, which means basically it's an argument because they have to pick a problem they haven't been able to agree on for a long time and then try to resolve it, which, of course, is not going to happen in a 10-minute lab interaction. So it pushes them in a way to kind of regulate their negative affect and deal with someone that they can frequently get into conflict with at this age. In any case, what she found was that guys whose mothers showed less positive affect in these observed contexts with them when they were younger had a different pattern of brain response. So the guys whose moms showed less positive affect showed the pattern we see in depression: more medial PFC, less striatum. Interestingly, though, that was only the case for those whose mothers had a history of depression. So there's this interaction of mother's mental health history by mother's behavior in predicting son's neural response to reward. Again, when people see these data, they always say, what does it really mean? Do you really think that the way mother behaves at one age is affecting brain development or brain function at another age? Isn't it possible that they just have these common inherited characteristics, like, for moms to be more positive and for sons to show this pattern of neural response? Maybe that's just some common thing that they have because they're genetically similar or something like that. And I wouldn't disagree that could be part of what's going on. Although I think it's interesting to know that certain patterns of physiology or behavior might be more sensitive to the experienced social context than others. So again, if you're in the guys whose moms had not had depression, whether the mom was more or less positive wasn't related. But for the guys whose moms had depression, there was more sensitivity. So if your mom showed more warmth and more positive affect, you were more likely to have a more typical looking pattern of brain function compared with depressed kids. So that could be something interesting to know, that there's something important maybe about mother's mental health. If there is a role for mother's behavior, that's something we can intervene in pretty easily. So if it's true that mothers who are more positive and warm, produce some kind of different, more optimal outcome, that's not a difficult thing to help families with. So that would be promising too. And furthermore, I have to say, I'm just excited to see an 18-year association of anything with anything. I mean, it's pretty remarkable in the kind of work I do. I'd be amazed to see someone's behavior was related to their own brain function 18 years later. So to think that a mother's behavior is related to her son's brain function at a different point in development is pretty cool. And so again, I think a lot of these are sort of, qualified interpretations. We can't make a strong conclusion, but one possibility is that maybe neural reward circuitry is sensitive to early experiences in kind of social affective contexts, and to behavior by important people like parents. Or maybe that positive parent-child relationships or behavior can be a foundation for healthy brain development. And I should note that in many meta-analyses, maternal warmth is kind of the universal protective factor, that if you have a mother who's positive toward you and warm toward you, you can have all kinds of other risk factors in terms of your own temperament, your own behavior, your social context, but you can be protected against maladaptive outcomes by having this. So it's a really important quality in families. So again, this could be an important way that they promote kind of healthy development. Similarly, I'll show it now, we have a similar finding in a different longitudinal study. In this case, this is a study of girls who are at high risk for depression. It's a big sample, recruited also in the Pittsburgh area. And in this case, a current postdoctoral fellow who works with me, Melinda Casement, did a project saying, can we understand, she's interested in stress and how it might dampen reward responding. And she said, can we say something about how stress experienced at one point in development might be related to brain function at another point in a way that's relevant to depression? So what she found was that by counting up, by kind of considering two different factors, in this case, I'm actually going to go back to maternal warmth. So girls who had less maternal warmth experience reported by themselves and their mothers when they were early adolescents showed more medial prefrontal response at age 16. And then when we kind of constrained this by this and said, okay, within this area where maternal warmth was related to brain function and to response to reward, was there an association with depression? And so it turns out there was. Within this smaller cluster, within this bigger cluster, there was an association with depressive symptoms at the same time. And she did a mediation analysis, which is a little more of a formal test. This was just a conjunction analysis, but found that, in fact, brain function in response to reward was related to this, was kind of mediating this association between maternal warmth early in adolescence and depressive symptoms later in adolescence. Again, we didn't measure brain function before, during, and after. These things didn't temporally unfold the way we would like them in an optimally designed study, but it's still an intriguing hint that there could be something important about this social affective experience, and then the way you show a pattern of neural response to reward that's relevant to your mood or to your affective problems. Okay, I'm going to stop here.